this was the last problem that we have seen on Saturday. So we have asked to do this as a homework to everyone. So I hope this was done by every one of you, and all of you had got the desired results which was expected to be obtained by solving this all the 7 matrices and the 3 identities. So this was the graph which we had drawn by using the power system network which was given to us. So this was the power system network which was given to us, and based on this power system network, we have first drawn the graph, and then we have drawn the tree and co-tree, and then we have asked each one of you to solve this particular problem in terms of the all the 7 matrices, and similarly to prove all the identities. So this completes the first part of our unit number 1, which is related to the graph theory. Now let us come to the second part of the unit, which is called as the singular transformation. So second part of this particular unit is related to the singular transformation, and we have to solve the matrices by using the singular transformation method. So again, we have a set of formulas that will be used here in case of the singular transformation. So let us first write the formulas that will be used for the singular transformation one by one, and then start solving the problem. So the first YBus is equal to A transpose Y A. I will explain each and every formula which is written here. First of all, let us write all these formulas. Then we will see what all these formulas represent and what we have to do exactly with all these formulas. So we will come to know everything one by one. So here we are going to make use of the matrices that we have solved in our first part. So the first matrix that we solved was the bus incident element node incidence matrix, and with the help of that we have uh, written the bus incidence matrix. So this is the first formula which is related to the bus incidence matrix. The second formula will be related to the basic cut set matrix, as we are going with the sequence. So A represents bus incidence matrix, B represents basic cut set incidence matrix, and C represents the basic loop incidence matrix. So one by one we will write all these formulas A, B and C. So for Y bus we have A transpose Y A. Similarly we have YBr, that is equal to B transpose. First matrix is bus admittance matrix. Similarly YBr we have written BR represents the branch. So the name of second matrix is branch admittance matrix. And the third matrix is ZLoop. So loop means loop, basic loop, we all know this. So Z means impedance. So we will write here loop impedance matrix. Okay. So these are the three matrices that we need to calculate in the second part of our unit, which is related to the graph theory and the formation of the various admittance and impedance matrices using the singular transformation method. So we will see what this singular transformation states afterwards, but right now we will write all these three formulas and we will start making the matrices based on the given power system network. Um, so we will take one problem and we will see how the various matrices are formed accordingly. So we will take one numerical. Let's see. So this will be our example number 5. So just draw this graph, power system network. So I am drawing here, you also draw with me. So all these values are given. You find the per unit values of the. So this is the power system network which is given to us. Based on this, what they have asked, let us see what is the problem. So the problem is for the system shown in figure, find. So what all things are asked, let us see one by one. First, directed graph, comma tree and co-tree. This is the first bit that they have asked. Second bit, basic loop incidence matrix. This is the second bit that they have asked. Then let us see what is third bit that they have asked. So third bit is basic cut set incidence matrix. This is the third bit that they have asked. Let us see what is the fourth bit that they have asked. So in the fourth bit they have said verify CB is equal to minus BL transpose. So this is the identity which we have already proved. Then fifth point what they have asked, let us see, form loop impedance matrix. Now check the problem what is asked. Now instead of incidence they have asked impedance matrix. So just now we had written the formula for loop impedance matrix. Values of self impedances are given in per unit. So all these values which are given, that is given in terms of the per unit values, you can see here in the problem itself 0 0.1, 0 0.43, 0 0.2, 0 0.3, 0 0.1, 0 0.22. So all these values are in per unit system. So we have to make use of all these values. And one more condition that they have given in the problem is consider the elements connected between buses 1 and 4 and between 3 and 4 as links. So please underline this because this is the condition which is given to us. We have to take this condition and then solve the problem. Otherwise, if we will make the links as per our choice, then the condition which is given here will be violated. So we need not violate any condition which is given in the problem. Okay. So this is the problem, and now we have to solve this problem and find out all these points one by one. So directed graph, tree and cotree, this without this you cannot proceed to solve any of this matrice. So the first bit you will get immediately when you will draw the directed graph, tree and cotree. Then basic loop incidence matrix, basic cut set incidence matrix, verify CB is equal to minus BL transpose, and form the loop impedance matrix. One by one, you have to find out all these matrices. But before this, the very first step is to draw the graph, tree and cotree. Okay, is it clear everyone? So this is an altogether new problem. It is repeatedly asked in the university question paper. So repeatedly university has asked this question many times, so you all have to solve it very carefully. So first I will draw the graph and I will explain how to draw the graph of such type of the numericals, and then we will move ahead to solve the various bits which is asked one by one. So just remember that whenever such type of power system network will be given to you, first, try to make the graph as simple as possible. If the graph is simple as possible, then your each and every matrix that you will be making will become simpler. Otherwise, if you will draw the graph in a complicated way, then your matrix will also become a bit difficult to understand. So let me write here. So for drawing the graph of this particular problem, what you have to do here is, you know that the reference point is to be connected with the buses where the generator is connected. So can anyone tell me where the generators is connected? So here we have 4 buses. So can anyone reply in which buses the generators is present? Yes, please reply fast. Which are the buses where the generator is present? Okay, only one, because there are 2 generators here. You can see here there are 2 generators connected. Yes, 1 and 4. So buses 1 and 4 are having generators to it, and till this is the 5th problem. 4 problems we have already solved previously. So when you will see the when you will see all these problems, you will see that the buses where the generators are connected should be on the same level. Rest of the things can be up and down as per the requirement of the numerical, because you need to connect the reference node, that is node number 0, with these 2 buses which are having generators in it, right? So what we will do here, we will make our graph in this way. So let me draw the graph here. So this is my reference node 0, and as I need to connect the bus number 1 and bus number 4 with the reference bus, I will write the bus number 1 and bus number 4 in this way. Then what is the leftover? Leftover is 1 should be connected to 2 and 2 should be connected to 3, or else 3 should be connected to 4. So I will draw 2 and 3 in this way. Alright, so let me join one by one. So this is the generator points. So I will join the reference nodes in this way. Then go back to the original power system network and check the connectivity. So 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, and 1 is also connected to 4. So let us first draw that here and then give the directions that is given in the power system network as it is. We cannot give the directions as per our choice. Okay, is that clear everyone? Whatever direction is given, we have to take that only. So this is the directions from generator to bus number 1, from generator to bus number 4. You can see this is generator. From generator we have given the direction towards the bus, so this is that direction. Similarly, from generator towards the bus, this is that direction. Now from 1 to 2, it's the direction from 1 to 2 in this way, so we will put the direction in this way, 1 to 2. Then 2 to 3 we can see here, from bus 2 to bus 3 it's going. Then here in this case 3 and 4 we can see, from 4 3 to towards 3 it's going. So we will make the direction in this way, from 4 to 3. Then in case of 1 and 4 you can see, from 4 towards 1. This is the direction which is given in the problem. So from 4 towards 1. So that we will be replacing here, from 4 towards 1. So this is the directions which is given as per the problem. So let us give the numbering to all these points. So what I will do here, I will make the numbering in this way: 1, 2, 3, 4, 5 and 6. Why? Because see, read this condition what they have given. The condition is the elements connected between buses 1 and 4 and between 3 and 4 as link. That means you have to choose this element and this element as link. So why I have given this elements as the last numbers? Because you all know it becomes easy for us to write the matrix if we have the first elements as branches and the last elements as the links. Is it clear why I have put the numbers in this way? In this fashion, why I have put the numbers? Number of elements. Okay. So let me write here then ENBL as we used to write. So ENBL. So what are the total number of elements here? What are the total number of elements? Okay, so total number of elements is 6. Last number is 6, so total number of elements is 6. Then nodes, you can see here total 4 buses are there and one more reference node is there. So 4 plus 1, that is 5. Then branch will be n minus 1, so that is 5 minus 1, so that is 4. And then L will be E minus B, so we have E minus B as 6 minus 4, that is 2. So already see, you can see they have already said that there should be 2 links, and the 2 links as per their choice is 1 and 4, between 1 and 4 and 3 and 4. So 1 and 4 is 5 and 3 and 4 is 6. So 1, 2, 3 and 4 will be branches and 5 and 6 will be links. So this is your graph, and when you will, this is your oriented graph, and when you will show the links here, then it will become trees and tree and co-tree. So let us draw the tree and co-tree separately. So this is the directed graph, and with the help of directed graph we are supposed to draw the tree and co-tree. So we will draw the tree and co-tree in this way. So I will write here tree So we will draw the tree and co-tree in this way. So the tree and co-tree will be in this way. So here you can see we have shown the branches and the links. So when you draw the branches and the links, that becomes tree and co-tree. So this is the answer of the first bit. So now just replace all the values of the self impedances which is given in the problem. One by one we are going to write the self impedances. So you can see from generator towards 1, the self impedance of this value is 0.1. So I will write here in bracket 0.1. Similarly, from generator to bus number 4, this value is also 0.1. So I will put 0.1. So this is already given in the power system network, so you can copy it from there. Then from 1 to 2, the value is 0.2. So I will write here 0.2. Then from 2 to 3, it is 0.22. So I will write here 0.22. Then from 3 to 4 or 4 to 3, the value is given as 0.3. So I will write here 0.3. And from 4 to 1, the value is given as 0.43. So I will put here 0.43. So in this way, we have successfully drawn the tree, co-tree, and we have also given all the values which are provided to us in the numerical. Now we are ready to solve our problem, the various bits which are asked in the problem one by one. So let us write the second bit. So till here the first bit is completed. First bit they have asked you graph and tree and co-tree. So this we have completed. In the second bit what they have asked is basic loop incidence matrix, so which is denoted by C. So for C you all know that what is the requirement. For C the requirement is to close the loops one by one, and whatever path is formed, that is to be written in the problem. So we will draw the graph once, we will draw the tree and co-tree once again, and then we will close the, because this is the answer of the first part, right? So first bit's answer. So we will not do anything in that. Instead of that, we will make another tree and we will make all our loops in that tree. Okay. So this is first element, this is fourth, then this is second, this is third. Now what we are going to do is we are going to close the loops one by one. This is third node and this is fourth node. So we are going to close the loop one by one. So let us close the first loop. The first loop is 5. So if we close this loop, what is happening is a loop is formed and the direction of the loop will be the same as the direction of the link. So this will be our loop, and the name of this loop will be, you all know the first names are given to the branches. So A, B, C and D is reserved with 1, 2, 3 and 4. Now what about this name then? This should be D. So we have given the name as D. Then we have the next link. The next link is 6. So this is 6. Don't forget the direction. If you will write the directions in wrong way, then your loop will become wrong. Okay. Now let us make a different color for this. So you all know how to make the loop. The loop will contain only one link and rest all the branches. Okay, otherwise you will be getting into confusion that whether this loop is to be taken or not. No, if you take this loop, it will be wrong, because in this loop there are two links. So at a time there should be only one link which you have closed to form the loop. So that's why the loop will be in this way. So it will start from here, then it will move to here, then here, then it will go downwards in this way, then it will go upwards in this way, and finally it will touch, return back to the position. So I will give this name after D, sorry, the name of the previous matrix should not be D, it should be E, right? So that should be E and this should be F, because D is reserved for 4. So this is E. Okay. Then after E we have F, so this will be F, and the direction will be in this way. So put all the directions so that you can write the matrix correctly. Okay, so are you all ready to write the matrix now? Because we have already shown both the loops, that is E and F. So now we can write the matrix C. So C will be equal to 1, 2, 3, 4, 5, 6. Again, I am repeating why we are able to write all this sequence 1, 2, 3, 4, 5, 6, because we have chosen 1, 2, 3, and 4 as branches and sequence because branches and links were different. So here in this case, what we have done is we have chosen our branches and link in such a way that the first elements are branches and the last elements are links. That's why we are able to write our matrix in this way. Okay, so now one by one we will start filling our columns E and F. So E is the red portion, red loop, and F is the green loop. So E we will start, see we have made E by closing the fifth element. So this should be positive always, and we have made F by closing the sixth element. So this should be always positive. This two cannot be negative, right? Then one by one we will fill. So you can see here the red loop is going downwards, whereas your element 1 is going upward. So 1 should be -1. Then your red loop is going upward as well as element 4 is also going upward. So 4 will be positive. Then when we go to F, we can see the elements are 6, 3, 2, 1, 4. So there are many elements. So let me write here the set of E and F. So E will have 5, 1, 4, and F will have these elements 6, 3, 2, 1, 4. So if you will skip any of the elements, your problem will be wrong. So please ensure that all the elements are filled. So let us start with 3. So you can see your loop is moving left side, whereas the 3 is going right side. So 3 should be minus. Then the loop is going downward and 2 is going upward. So 2 should be minus. Then loop is going downward and 1 is going upward. So 1 should be minus. Loop is going upward, 4 is also going upward. So 4 should be positive. Rest all the fields will be replaced with 0. Okay. Is it clear everyone how we have written the basic loop incidence matrix C? So once we write this basic loop incidence matrix C, we have to make a partition of this, and when we make a partition, the partition is always made with reference to the branches and the link. So here the partition can be made in this way. So the upper portion is branches and lower portion is link. So why we require this? Because you can see in the fourth bit they have asked you CB is equal to minus BL transpose. So anyways, we will require this. That's why we are writing here CB. So CB is -1, -1, 0, -1, 0, -1, and 1, 1. So this is your CB matrix. And similarly, this one is CL matrix. Even though we are not in requirement of CL matrix, but still we will write here. Okay, so this is your second bit which they have asked, that is basic loop incidence matrix. Okay, so let us write here second answer. Okay, now let us go to the third bit. What is third bit? Third bit they have asked basic cut set incidence matrix. So we will start solving the third bit. So third bit is to find B. For this, we need to draw the graph once again. Sorry, tree and co-tree once again. So just we will draw the tree and co-tree once again and write the various parts. So this is 1, this is 4, this is 2, this is 3, then these are the links, this is 5 and this is 6. This is node number 1, this is node number 2, this is node number 3 and this is node number 4. Now you all know number of basic cut sets is equal to number of branches. So you all know this. So here there are 4 number of branches. So that's why basic cut set will be also equal to 4. So there are 4 number of branches. So that's why there will be 4 number of basic cut sets here. So basic cut set will be written name as A, B, C and D. So let us cut this basic cut sets and write the various values. So you all know how the basic cut sets are cut. So when we cut one with 1, the link should cut. With 1, 2, 3, 4 should never cut, because 1 is a branch, 2 is a branch, 3 is a branch and 4 is a branch. So with a branch, another branch should never cut. Otherwise your basic cut set will not be proper. So we have to give the name with reference to the direction of the branch which we had cut. Okay. Similarly, when we cut 2, the 2 will be cut in this way. So 2 and 6 will cut and give this name as B. Then when you will cut 3, you will cut 3 in this way. Give the name C. Sorry. And the direction will be in this way. So this is C. And when you will cut 4 in this way and give the name accordingly D. So these are your 4 basic cut sets. And now write all the entries of this basic cut set. So what will be the entry of A? Let us write first. So the entry of A will be 1, 5, 6. Entry of B will be 2, 6. Entry of C will be 3, 6. And entry of D will be 4, 5, 6. So this will help you to cross check whether all the entries is filled properly or not. So once you are done, you can start writing your basic cut set. So I will write here B is equal to 1, 2, 3, 4, 5 and 6. And then the basic cut sets here in the horizontal line, A, B, C and D. So in this way we have made the things 1, 2, then 3, then 4, then 5 and then 6. So these are the entries that we need to fill. So we will start filling one by one the entries. So you all know that the first entry is 1, 5, 6, right? So this is the first entry. You can check it. See, we have written 1, 5, 6. But in 1, 5, 6, we are not able to choose what will be the common point, right? So when we don't get anything common in between the things, then we will choose any one point as the common point and we will start the solution accordingly. So here you will, what we will do is we will take this node A as the common point. So for this node A, we have already put this as the reference direction. So this 1 will be always positive. For this B, 2 will be always positive. For this C, 3 will be always positive. And for this D, 4 will be always positive. Why? Because based on this only we have given the direction. See, the direction of 1 and direction of A, both are same. The direction of 2 and direction of B, both are same.
direction of 3 and direction of C both are same, as well as the direction of 4 and direction of D is same. So that's why these elements can never be negative. Okay. Now, in case of this node number 1, this 1 is incoming. That means all the incoming should be positive. So you can see 5 is also incoming, and this 6 will be also incoming because its direction is upward. So it will move till here, then from 3 it will go to 2, and from 2 it will come to 1. That means 4 and 5 will be also positive. Sorry, 5 and 6 will be also positive. So we will take here 5 and 6 also as positive. Then in terms of 2 and 6, you can see the common point is very simple. For 2 and 6, again, yes, it's not simple. For 2 and 6, you can see that the directions, there is nothing common in between, right? So if there is nothing common in between, then let us take any one point as the reference point and then move accordingly. So let us take the common point as node number 2. So for this node number 2, this 2 is incoming, which is already positive, and this 6 will be also incoming. So that's why 6 will be also positive. So we will put here the entry of the 6 also as positive. Then in case of 3 and 6, it's easy for us because in case of 3 and 6, we can very clearly see that node number 3 is common. So node number 3 is incoming. So incoming is positive. So both 3 and 6 are incoming. So let us make 3 and 6 as positive. So this will be also 1. Then in case of 4, 5 and 6, we can see this node number 4 as common. So if node number 4 is common and this 4 is incoming, that means incoming we have already made positive. That means outgoing should be negative. So both the 5 and 6 is outgoing in case of this. So we will put here both the 5 and 6 as negative. Okay. Rest all the things are to be filled by 0. So in this way, basic cut set incidence matrix also is calculated. After this, let us partition it, because unless and until we make a partition, we will not be able to prove the fourth identity, fourth bit that is to be proved, that is CB is equal to minus BL transpose. So we will make a partition, and in this partition, this is BB and this is BL. So we are interested in BL, so we will write here BL 1 0 0 minus 1 1 1 1 minus 1, and this is a unity matrix. So this is very simple: 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. This is the BB matrix. But we are not interested in BB. We are interested in BL. That will prove our fourth bit, that is the identity part. So this is the third answer. So let us write here as third answer. Now coming to the fourth bit, what they have asked is to prove the identity. What is the identity? Fourth bit, we have to prove the identity CB is equal to minus BL transpose. So let us write first CB. LHS is equal to CB. So what is CB? We have already solved this previously. So this is CB minus 1 minus 1 0 minus 1 minus 1. So this we will write here. CB is equal to minus 1 minus 1 then what is the second entry? Zero minus 1 0 minus 1 and 1 1. So we will write there 0 minus 1 0 minus 1 and the last one is 1 1, right? So this is our CB. Now RHS we have minus BL transpose. So first let us write BL. What is BL? BL is 1 0 0 minus 1 and 1 1 1 minus 1. So if we will multiply this by minus sign, so this will be minus BL, so this will be minus 1 0 0 1 and this will be minus 1 minus 1 minus 1 1, and when you will make it minus BL transpose, so this will be minus 1 minus 1 0 minus 1 again 0 minus 1 and 1 1. So this you can see this is equal to CB, therefore LHS is equal to RHS. So this is your fourth bit, hence proved. So this is fourth answer. Okay, so we have already proved this identity yesterday. Now the fifth bit is new to us. So fifth bit we have to solve. So fifth bit what they have asked, just let us check it. So fifth bit is they have asked us to solve the loop impedance matrix. That means they have asked us to solve Z loop. And we have the formula for Z loop. What is the formula for Z loop? Z loop is equal to C transpose ZC. Let us see what is the meaning of this. So for this C transpose, you already have C. So you can make the transpose of that and make C transpose. You already have C, only the part that you don't have available with you is the Z matrix. So we will first write the Z matrix and then we will start the solution. So Z matrix is basically a element by element matrix. So this Z matrix is element, I will write here. So this Z matrix is element by element matrix. To ask something, you have unmuted your mic. So Z matrix is a element by element matrix. In this case, what is the total number of elements? In this case, the total number of element is 6. So this Z matrix will be a 6 by 6 matrix. Okay. This Z matrix will be a 6 by 6 matrix. Let us see how this Z matrix is written. So for this, what we have to do is we have to write all the values of the diagonal values with the element values, and rest all the values we have to put 0. Why? Because this is a primitive impedance matrix, and the concept of the primitive impedance matrix is we have to consider the self impedances of all the elements, and the off diagonal matrix, that is upper triangular and the lower triangular elements, will be 0, because we are not going to consider the mutual impedances between the elements, whereas we are going to consider only the self impedances which are given in per unit values in the problem. So let us go back to the tree and co-tree where we have written all those values. See, you can see here 1 means 0.1, 2 means 0.2, 3 means 0.22, 4 means 0.1, 5 means 0.43 and 6 means 0.3. So we have to write all these values one by one. So let me write here. So 1 is 0.1. So rest all the values will be 0. I have said that this will be a 6 by 6 matrix. So you can check 1, 2, 3, 4, 5 and 6. So all values, all the upper triangular and lower triangular values will be 0. Next, we will start with 0, and here the second value, which is of element number 2. So element number 2 self impedance is 0.2. So I will write here 0.2. Rest all the values will be 0. Similarly, the third row, so 1, 2. So 0, 0. Now the third element. So third element is having the self impedance of 0.22. So I will write here 0.22. Rest all the things will be 0. Similarly, the fourth row Z44. So fourth element is 0.1. So I will put here 0.1. This all I am taking from the given numerical, the values which are given in the numerical. Then the fifth element is having 0.43. So I have put here 0.43, and the last is 0, 0, 0, 0, 0, and the last value is 0.3. So in this way we have calculated the Z matrix. So you can see that this is a 6 by 6 matrix. So whatever number of elements will be there in the problem, the matrix will be taking the shape accordingly, element by element. As in this particular problem, the total number of elements is 6. So that's why we have obtained a 6 by 6 matrix. Is that clear, everyone? Whenever we will have different variety of problem, we will take again 2 or 3 problems related to this. Then you all will be able to know how this matrices are taken. So is that clear to everyone how we have taken this Z? Because to solve this Z loop, you were not having Z. Now you are having Z available with you. So you can put all these values in this particular equation and you can calculate the Z loop. So let us calculate the Z loop. So we have C available with us. We have Z available with us, as well as we have C. If C is available, we can. So Z loop will be equal to, I will again write the formula. Z loop is equal to C transpose ZC. Now I will replace one by one the values of C transpose Z and C. So C transpose, you all have C matrix available with you. You can directly write the transpose. I will write here. You can write in your copies. So this will be -1, 0, 0, 1, 1, 0. Right? So this was C. With the help of C, I have written the C transpose matrix. This is -1, -1, -1, 1, 0, 1. This is C transpose. Now multiplied by Z matrix. Z matrix we have written just now. So I will just copy it from there. 0 0.1, 0, 0, 0, 0, 0. 0, 0 0.2, 0, 0, 0, 0, then 0, 0, 0 0.22, 0, 0, 0, then 0, 0, 0, 0 0.1, 0, 0, then 0, 0, 0, 0, 0 0.43, 0, and the last is 0, 0, 0, 0, 0, 0.3. So this is your Z matrix. And similarly C. So what is your C matrix? So just now you have made the transpose of that. So you can write from there -1, -1, 0, -1, again 0, -1, then 1, 1, then 1, 0, and then 0, 1. So this is your C matrix. So now see, I will write here. If you are not able to understand, please check it out. This is which matrix? This is C transpose matrix. This is which matrix? This is primitive impedance matrix. This is which matrix? This is C matrix. So now your task starts now. You all are familiar how to multiply the matrices. So you will multiply the matrices. You all know the procedure how to multiply the matrices and write the result. So I will write the final results here. You can cross check it by multiplying each and every terms. So I will just write here the final results which we are getting. So the final result you should get is 0.63, 0.20, 0.20, 0.92. So this should be the result that you should obtain, and this will be the answer of your fifth bit.